Okay, so basically I watched Veritasium's video today, and it got me thinking the entire day, I have to say, but I came up with some theories for it, I guess. So basically, in the first scenario, the bullet shoots exactly into the block, and then it flies up. And in the second scenario, the bullet shoots to the side of the block, and it also flies up, but it also rotates. So, well, I read through the comments, and some people suggested that the bullet here actually went in not as deep, or deeper, I forgot, as the bullet here. Well, so this is the VT graphs I drew, and so you could tell because the bullet and the block all had the same masses in the first and the second scenarios. Their acceleration had to be the same because of F equals ma. So they had to meet up in the same place, meaning that the area of this triangle here must be equal to the area of this triangle, meaning that the bullet had to be in the same place inside the block. So for me, that I thought that this bullet went this bullet went through deeper too, to give it that extra push, but as it turns out, I feel like I just debunked my own theory anyways. So here, I actually tweeted to Veritasium about this and asked, does it have anything to do with momentum? And he sort of gave me a hint that it does. So I went down the momentum line, and I thought I came up with some pretty interesting results. So as we all know, P equals mv, that's the equation for momentum. And so in the first scenario, the bullet shoots in, and then it stays there, the block doesn't rotate, and it flies up. So in this scenario, if we use so basically, like, the momentum that it begins with is equal to the momentum in the end, we get let's assume the bullet's mass is m0, the block's mass is m1, the bullet had an initial velocity of v0, and the block, after the bullet hit it, the block's velocity was v1. So we get m0 v0 equals m1 plus mo times v1, and so we come up with this very interesting equation here. And for the second one, since the mass of the bullet and the block didn't change, we also get this one. But I felt like looking at the second one as two separate blocks. So we have the right block, which the bullet is shooting into, and the left block, which the bullet doesn't touch at all. So I just set another variable here and let the right block have the velocity v2 whenever the bullet hit it. And so I solved for v2. It was equal to m0 times v0 over a half m1 plus m0. And basically here was me solving that v1 is actually less than v2. So that means this had a bigger velocity than the entire block moving upwards, making it rotate, and therefore it had that extra rotational energy up there, whereas this one didn't. But where did the extra rotational energy come from? I think it was mainly, so for this part, it shot into it and it gave it a force this way. It actually, think of it this way, without the left part, this would have went up higher than this. So basically the left part was keeping the block slow. And so I feel like in this, the bullet actually lost some energy here, like trying to drag the left part up as well as the right part. So to make up for that negative amount of energy, it had that extra rotational energy up here. I don't know if I'm right, but that's my hypothesis. But I'm pretty sure these are right. Anyways, yeah.